On this part now we are going to talk about torque and balance or equilibrium of objects. Okay, for example, now if I have here a wall and there is a bar here that is stuck to this wall. Okay, if for example now the length of this one now here to here is 1 meter, 1 meter, and here that means 2 meters, and here is what? 3 meters. Okay, if I decide to break this bar from this part now, I want to break this yellow bar from the wall. What's the way to break it with my hands or with pushing a force? So that means I'll go from here and I push with a force, or I'll go from here and I push by force, or from here. So that means I have 3 choices. At which point when I exert my force at that point will be easier for me to break it. At which point? Of course, it's gonna be this point. So at this point now will be the easiest way to break this yellow bar. Okay, why? Because now when you make force here, you try to push it down. That means you are trying to rotate it. Clockwise rotation. When you are trying to rotate something, what is responsible for the rotation is not only the force. It's the force times the distance between the force and the center of rotation. This one is called the center of rotation because you want to rotate this bar around it. So that means this distance now between the point that where the force exerted and the center of rotation plays a great or a vital role in the magnitude of the ability to rotate something. So that means if you want to rotate something, this causes the torque, and the torque, by the way, it equals the force itself times the distance of rotation, times the distance or the distance between the point of where the force exerted and the center of rotation. So the greater the distance, the greater the torque. So that means if you want to rotate something, whether to break it or to rotate it along, your goal is not only to exert higher force. No, your goal is to exert higher torque. So that means higher torque is satisfied either by increasing the force or by increasing the distance between the force and the center of rotation, or by increasing both the force and distance. So that means if you want to break something, so that means you want to increase the torque. To increase the torque, you can increase it by, as I said, this one or this one or this one. Okay, another example just for the torque. If I have a door, and as you see, the door here always, where do we put the handle of the door? That means we open the door. Where do we handle or we grasp or the door to open it? Always we put it here, and the rotation is here, the center of rotation here. So we always push the door from this point or pull it from this point exactly. So we don't put this point in the middle of the door. No, we put it here. Why? In order to get the farthest possible distance from the center of rotation. So that means we want to increase the distance from this axis of rotation to the point we exert our force. So the higher the distance possible will give us the higher possible torque. So that means when I get the higher possible torque here, so that means I reduce the force to as much as possible. So that means if the torque needed to open the door here is 12, okay, the torque is 12 with its unit. So if you want to increase the distance, or the distance, if it is 1, if the distance is 1, that means you need 12 Newton as force, because this one times this one will give you this one. Okay, so if you want to maximize the distance to 2, so that means now you are reducing the force. Instead of needing 12, you need only 6, right? If you want to increase the distance to 3, so that means you need only 4. If you want to increase this one to 4, so that means you need here 3. If you want to increase this one to 6, so here you need 2 in order to get what? 12. So again, if you want to rotate something, your goal is always to maximize the torque. How to maximize the torque? Either by maximizing the force or the distance between the point of where the force exerted and the axis of rotation, or by increasing both of them. So what is now, again, this is now the formula of the torque, and make sure that the angle between the force that is exerting an object and the axis or the object itself has to be 90 degrees. If it is not 90 degrees, you need to multiply by the component that is perpendicular. So that means this one is only when it is what? Perpendicular. So that means torque equals force times distance. Okay, these ones is important in many things, in balancing many things. So for example, now if I have here a balance, and here I have one object here and one object here, and I want to put them in balance. Okay, if the distance here is 2 meters, for example, here and one here, 1 meter. So which one I should have greater mass? Which one has greater mass? Object A or object B? So look, this the mass of object B, when you multiply it by the gravity, going to be weight. This weight now, its direction is downward. So that means it's trying to rotate this part from this point here down. And this one now is trying to what? To rotate it from this part now down. This one is clockwise, and this one what? Anti or counterclockwise. So that means if this torque now counterclockwise and clockwise, and this torque now clockwise, if they are equal, this object will be at balance. Okay, to make it equal now, the torque here, T of A, it has to equal what? T of B, of object what? B. And the torque, as we said, it's gonna be here. It will equal what? Force times distance. And the force here, it means the weight. So that means it means gravity times mass times distance. So here gravity times mass times distance. Gravity will go by gravity because they are the same now. So that means what is matter now is mass times distance, and here what? Mass times distance. Okay, if the distance here is greater, if the distance here is greater, okay, the distance here, which is the distance here, is 2 meters. What should be the mass? Okay, for example, the mass is 6 here. Is 12. The mass here is 12 kilograms. Okay, that means it's going to be 2 times 12 here, 24 on this side. So this side has to be 24. So that means if the distance is only 1 meter, so that means the mass has to be 24 kilograms in order for these two parts to be in balance. So that means to make this part into balance here, if the distance here is double the distance here, so that means this mass has to be double this mass in order to make the two parts equal in their torque. Example here, if I have here is 1 meter and here 2 meters. We have here two objects. Okay, if this one now is 6 kilograms, okay, what should be the mass of this object here in order to make them balance? Again, the torque that is clockwise has to equal the torque that is what? Counterclockwise. And we said the torque, it equals here force times displacement, right? So that means force times displacement here, or some distance, it's gonna be m times gravity times distance. Since the gravity is the same for both of them, so that means I'll consider just the mass times the distance. So mass times the distance here in this part is gonna be m times d, which is 6 times 1. It's gonna be what? On this part, as you can be, it's gonna be 6 here. Okay, what about the right side? Here it's gonna be 2. 2 times what? It has to be 6 as well. So this one has to be what? It has to be 3. 3 times 2 is gonna be 6. So in this case, they're gonna be what? Equal. So that means this one is 1 meter distance, but 6 kilograms mass. But here 2 meters, so that means this one is 3, 2 times 3 is 6 is 6. Okay, when an object here, this is an object. It is at equilibrium when the sum of the forces is 0, the sum of the forces is 0 for any object, and the sum of the torques is 0. So for example, if this torque now, as you see, it equals 6 here, for example, okay, if we're not counting the gravity, but it has to be 60. If we say 6 here, so this one which is counterclockwise, this one here is going to be 6 what? Clockwise. So that means if clockwise make it positive, this counterclockwise will be negative. So when you add them here, you get what? 0. So if the torques clockwise equals the torques counterclockwise, that means the sum of the forces are 0. The sum of the torques are 0. If the sum of the torques are 0 and the sum of the forces that is downward and upward of an object is also 0, the object or the system will be at equilibrium.